All right, let's get right into it. Today, we're diving under the hood, metaphorically, of course, of the electric car. We're going to demystify the elegantly simple yet ridiculously powerful technology that makes these things move, the electric motor. If you've ever ridden in an EV, you know exactly what I'm talking about. The second you touch that accelerator, the car just goes. There's no noise, no drama, just boom, instant speed. So what's the secret? How do they do that? Well, the whole secret sauce comes down to one little phrase: instant torque. And really, all that means is that an electric motor can deliver 100% of its power, its turning force, from a dead stop. There's no waiting for an engine to rev up. It's just all there right now. Okay, so how does that power actually get from your foot on the pedal to the tires on the pavement? Let's follow the energy. You'll see it's a surprisingly simple and direct path. So it all starts in the battery pack, which stores its energy as direct current, or DC. Now, when you press the accelerator, a motor controller, which is basically the brain of the operation, figures out exactly how much power you're asking for. It then tells an inverter to pull that DC power from the battery, flip it into alternating current, or AC, and shoot it over to the electric motor. And it's that AC power that actually makes the car move. And that brings us to the heart of the machine itself. Inside that motor, what's happening is this incredible little dance between two main parts. There are no explosions, no pistons flying around, just pure, clean physics at work. First up, you've got the stator. Now, as the name kind of implies, this part is stationary. It's the outer casing, and it's wrapped with a whole bunch of copper wire coils. When that AC electricity we just talked about flows into these coils, it generates a magnetic field that rotates electronically. And then, sitting right inside the stator is the rotor. This is the part that actually spins, and it's connected to the wheels. The rotor has its own magnetic field, and its whole job really is to get dragged along by the spinning magnetic field of the stator. So let's picture this. The controller is sending electricity to the stator's coils one after another in a super fast, precise sequence. This creates a magnetic field that's basically chasing its own tail around the inside of the motor, all without a single moving part. It's like an invisible force just spinning in a circle. And here's where the magic happens. That rotating magnetic field from the stator essentially grabs onto the rotor's magnetic field and just yanks it along for the ride. It's this constant, powerful magnetic pull that forces the rotor to spin and spin and spin. And that right there, that pure, direct magnetic force, is exactly what you feel as instant torque. It's not like a gas engine that has to make a bunch of tiny explosions to build up pressure and force. Nope. This is physics doing its thing directly and immediately. No lag, no waiting. Now, while that basic principle holds true for all EVs, car makers tend to use two main designs for their motors, and they each have their own kind of personality. Let's take a quick look. Okay, on one side, you've got the AC induction motor. Think of this as the reliable workhorse. It's tough, it's cheaper to make, and the stator's field actually creates or induces a magnetic field in the rotor on the fly. But then you have the permanent magnet motor, the PM motor. This one's the high performer. Its rotor has powerful magnets built right in, so its magnetic field is always on. The stator's field just locks onto it directly. And what that gets you is way better efficiency and a ton more power in a smaller, lighter package. And that, right there, is why these PM motors are pretty much the standard in most new EVs today. So we've gone through all this cool engineering, but what's the actual payoff? Why does all this elegant simplicity matter? Well, it leads to some pretty huge advantages over your old-school gasoline car. And the biggest advantage is efficiency. I mean, the difference is just staggering. Take a look at this. A regular gas-powered car only manages to get about 16 to 25% of the energy from its fuel to actually turn the wheels. Where does the rest go? It's just wasted as heat and friction. An EV, on the other hand, converts a whopping 87 to 91% of the energy from its battery directly into motion. To put that another way, an electric vehicle is 3 to 4 times better at doing its one main job, moving you down the road. It is just a fundamentally more efficient machine. It's not even a close competition. And that beautiful simplicity just keeps on giving. Because you have so many fewer moving parts, there's way less to break and way less to maintain. We're talking no oil changes, no exhaust systems, no complex transmissions. The ride is totally silent and perfectly smooth because there are no gears to shift. The power just flows from the motor through a simple gear and straight to the wheels. That's it. So when you really look at it, the EV motor is this masterpiece of efficient engineering. It's so good at what it does, you could almost argue it's a solved problem. And that leaves us with a really interesting question to think about. If the motor is already this good, where will the next big leap forward in EV performance and technology actually come from?